Okay, so we continue from where we were. Um, Remember, this is just kind of going through things that by now we have at least heard of before, have understanding of. The chapter is just miscellaneous, adding some revision to these things. Now, we talk about Boolean. They are either true or false, right? They are true or false. So if you attempt to do something like, let's say, B equals Boolean of S. We've been talking about S before. Like you're just trying to extract the Boolean value of S. It's going to either give you a true or a false. But now this is the thing. A string that is empty will give you Boolean of false. But a string that is not empty will give you a Boolean of true, which is these strings will be true no matter what it contains, right? If you check the bool of a list, if the list is an empty list, it will be false. But once there's an item, it will be true. If it is an integer, 0 will be false, but any other number is true. So you could actually just check the Boolean of it. It's either true or false. And in using our if statement, I believe we also highlighted this where we say something like if S, let's say, how do I put it now? If we have T, maybe a flag. We've done this concept. If flag equal to true, we could have something like if flag equal to, then we have some action. You can write something like this, checking maybe if your flag is true. And said if it's equal to true, then do something. And this same statement can be written in a shorter form as this. Okay, because remember the expression in your if statement always evaluate to a Boolean, either true or false. So if you check this, if you evaluate this now, is flag equal to true? In this case, the answer will be what? True. Abi? Correct? This whole evaluation will end up being true. Which if it is written as a flag in the beginning and flag is just true, you can see that it's already there, true. So this is like a short form of doing this. Okay. So most times when you want to check is something true or false, you can just reduce it to a short form like this. So in case of where it is false and you're trying to check if it's not true. Because if it's not true, it's false. Without F. So you can then have the short form as if not flag. So this also now is checking if it's false. So instead of writing this, you can say if not flag is the same expression. Do you understand? Any question on that?
Sorry, I had a network glitch, so I was not from the time we started the Boolean. I had a serious network glitch. Just came.
Yeah, no problem. It's not done much in Boolean, different from what you knew, but we're saying that you can get the Boolean of every value. It could either be true or false. Yeah. And then for a list that is empty, the Boolean will be false. But when the list contains an item, it will be true. An integer of 0 will be false. Other integers, true. An empty list is false. Why list containing an item is true, whether one or more items. So we then went ahead to talk about this case where you can write this in a short form. For instance, you're saying if flag is equal to false, then we're checking, say if flag is equal to false, now do something. And we're saying we can rewrite this expression as if not flag, because you're checking for the case where it's false. Okay. Because, okay, now if you want to literally understand this, when you say if flag is equal to false, this will return true, right? Because flag is false in this case, isn't it? So if you evaluate this statement, it will be true. Now, when you now want to have not flag, if you come and have a scenario where you do if flag, remember flag is false, so this is now saying if false, then as a if false, remember flag is false. So once you just say if false, what you're not trying to say is do not execute this. Because for you to enter your if statement and execute the actions here, the evaluation here has to end in a true. So the only way you can get that is when you then have the not, which will change this false again now to be true. Then this statement will be executed. I hope that's not confusing.
Yeah.
Okay. You can also store for instance, instead of just doing this, you can, if you want to store it as a variable, you could have something like maybe p is equal to you can compare some things like this and store it as p. It might not be flag, or like you can just say p is equal to maybe where maybe a is defined, because a has to be defined before here. So let's say a is equal to 3. I can store this in a variable, but it's going to be a Boolean because this expression will just evaluate to either true or false. Whatever it evaluates to, I can store it in P and maybe use it somewhere in my code. That's something else you can do. Then another part we'll talk about is shortcuts. Another shortcut, yeah. I'm sure all of us by now should be aware that this is the same thing as, right?
Yes.
In the
Confirm.
same vein, this is also equal to, okay. In the same vein, say b equal to p times a. You can still say b times equal to A. And for divide too. So these are some shortcuts that we should be familiar with by now. When you start seeing all this in codes, you shouldn't be confused. At the beginning, maybe the first time we mentioned it, you see that or the first time you come across it, you tend to struggle to relate both of them immediately. This is quite easy to understand, but then with time, you then understand is this. And a more advanced user should be conversant with this kind of shortcuts. And again, when we talk about assigning values, so if you have maybe three variables, which you want to say A equal to 1, B equal to 1, and C equal to 1, something like, because they are all equal, it can be declared in a single line as this. A equal to B equal to C equal to 1. And remember from our previous lessons, you find out that if you declare all of them like this, and you come later and say B is equal to something else, it doesn't change the fact that A is still equal to C and is equal to 1, right? They are not literally pointing to each other. They are pointing to these objects. Even though they are written like they are pointing to the object 1 in memory. Okay, so it's not like if you modify B, then it affects the value of A. Is that one clear? Then also for a list, if you have a list that is equal to, say, 8, 9, 10, and you want to assign each of these items in the list to variables, maybe you want to perform operation like A is equal to list 0, B is equal to list 1, C is equal to list 2. Of course, this would be 8, and then this one will be what? 9, and this would be 10. So you're assigning these variables to the values in your list, okay? And an easier way to achieve this would be to say A, B, C is equal to L. So once you write it like this, it's going to unpack our list in this order for us. So it's a simpler way. Instead of you doing it one by one, you could just achieve it in one line like this, unpacking the list item into different variables. Any questions so far?
It's clear.
Okay. And then the one of maybe x equal to 1, y equal to 9. If you want to swap these values, you can literally bring in maybe temp. I can store x in temp and say temp is equal to x. So which means temp is now equal to 1. Then I change x to be equal to y. And then I can say y is equal to temp. This is a way of swapping. At least you should understand this in literal terms. But in Python, to achieve this kind of swapping where you bring a temporal variable to hold one of the variables and then you change it so that the temporal one is holding what x is, so that by the time I assign x to y, I still have connection to the value of x, the previous value, which is 1. And then I can then assign it to y. If there is no temporal variable holding it, it's very difficult to achieve this thing. Because it's like once you make x equal to y, just assuming this line is not there. If this line is not there, the moment you just say x equal to y, when you want to change y to be equal to x, it will not be equal to 1 again. Do you get? So you use a temporal variable to do this. Now, in this kind of stuff, you can do it in any programming language, but in Python, you can also simplify it as x, comma y being equal to y, comma x. So instead of going through this route, you can just swap it this way. Now there's something called short circuiting. So when we look at an if statement that says something like, let's say I have a equal to 17, and I can say if a is greater than 10 and a is less than 100, do an action. So we can have multiple conditions in a line. So if this and even if it's another item, maybe we have b being equal to true. Somebody say and instead of this part, just say not b. Something like you're basically considering two conditions. Now, the moment Python checks the first condition, this is what I want to bring out here. The moment Python evaluates this condition, if this condition fails, Python will not even evaluate this condition. So if you have a series of conditions, this and that, and that, and that, and that, the moment the first one fails, Python just goes ahead because there is no way this whole statement will be true if one of them has failed. Now, why is this necessary? There are some times when you're doing some codings where you need to check conditions, and then you're aware that one of the conditions maybe does not hold all the time. You can put that condition first, because when Python is going to evaluate it, it's going to be one after the other. And when you're using an AND, everything must be true. So the moment it checks one and this one is not true, then it's not going to check. It will not even evaluate the other ones, which means even if there's an error somewhere, right? There's an error in the code in this side. It will even return that error. Let's say, let me put it this way. It doesn't know what B is. Let me say Z. Maybe there's a B up there. Something like this. So I've not defined Z, but then A is, let's say if A is less than 10, and then not Z, you can see that Python does not know what Z is. It's undefined. But if it's running this code, the moment it checks here and sees that is A less than 10, the answer is no. So once this is false, Python will not even bother checking this place. It will just continue. That's called short circuiting. It's just using the conditions to continue without checking the other one. Normally, other languages will check this, then check this, and it will detect the error that, oh, there's an error in this part of the code. So no, it will then flag the error. But this one now, if this code compiles and runs, you find out that you just check only this side and not this side. I don't know if it's clear.
Yes.
So if you run it, what will be the output?
It's in this case, it will not do anything because there's no action. But what I'm trying to say is that it's supposed to, it doesn't bother itself checking all the conditions you put in your statement, right? Once one of them has failed. How about mod equal to Peter? Sorry, before I go to Peter, did you understand? Is your question answered?
Myself?
Yeah.
Yes, confirm. Yeah.
So this I'm just giving you like an example off my head. Okay. Just an example of my head. This one, if I try to run it might even just bring an error that, oh, it doesn't know Z is, but it might do that immediately without even running the code. I'm not sure, but I'm just trying to say in a case where there's like an error, not syntax error per se, it will just evaluate, it short circuits once one of the conditions now is no longer holding. This is something you just need to have it at the back of your head. I've been writing a code and this kind of thing helped me to optimize my code, knowing fully well a certain condition doesn't always hold. So I put that condition first instead of evaluating it somewhere so that your code will not be evaluating all of them. If you put that condition at the end and you know that sometimes that one does not hold, but the others hold more often, it will, if you put it at the end, it will spend time evaluating all the conditions before it gets to that one. But if you know that it doesn't always hold, you put that one first. So anytime it doesn't hold, you're saving yourself time of instead of it evaluating all conditions. Once this one just fails, it just knows the whole statement cannot be true. That's short circuiting, just short circuit without completing the whole run. That's what I'm trying to say. Now, somebody asked a question I just saw in the chat to say, what about this? I believe, Peter, this is what you're trying to say. Something like this. If it has the shortcut of B mod equal to A. Is that what you're asking? Okay.
I was thinking this the percentage sign is an operator.
Multiplication requires operator. Division
For mode.
is the
Mode
modulus
operator.
operator.
Yeah.
So, but me now, I've not tried this before, so off my head, I can't say if this holds or not, but we can just quickly run it to see. Okay. If it's follows the same short shortcut, but typically I know this shortcut for plus, minus, divide, and multiply. But for modulus, it hasn't come across my mind to check. So if I can confirm, I'll just need to check it. But I kind of doubt if this B equals to B mod A, because that works. Let's just try it. Let's say B is equal to 7, and then A is equal to 2. So let's print B mod A. Okay. And then we'll also print B let's see how do we capture this now. Let me make this C, also C, and then because we have B mods equal to, so B mods equal to A. Then we then print B to see if we get the same thing. File. Doesn't make sense now for my code, so okay. Then I run it. It's actually the same thing. Can you see? So I have B equal to 7 and then A is equal to 2. So I just printed directly, okay, what is B mod A? Of course, it's 1. Then I perform this operation, B mod equal to A, and then I printed B because the value of B should have changed after this operation. And after printing B, find out that they are the same. So it's the same. Peter, exactly. Now, this is how, whenever you think about something like this, it's like conducting an experiment. Just try to put it in code and see what it gives you. Yeah, and then you learn how Python handles it. Okay. So even like the question that Nkechi asked, how can you bring when you're using .join, how can you print the joining item before and after? If you can think about how to implement that, you try it. Though for someone like me now, what I'm seeing now is you have to put an empty item first. Maybe you can think of a way to implement that. Then you try it, then you learn that, oh, this is possible like this. Or you go to documentation and read if you can do that. Because all these things we are using, all the functions like print and the rest we call in our code, we are written by people. They didn't fall from the sky. And when these people wrote them, part of a good practice is they will write a documentation to support them. For instance, if you end up writing a function that you find very useful and you want to share it with everybody to use, you will need to do proper documentation and then commenting of that code. When we get to functions, you will see some kind of comment they call doc string. You need to put that will give you some description. So others that want to use it can understand what you've done and use it. And also in you as a programmer, sometimes when you're solving problems, you go to Google and you see a solution. In that solution, maybe they imported a library you do not know about, but it seems to have given you an answer. Before you can use that library in your production code, which is code that you're using when you're developing an application, it is best practice to go and read about that library that you used. You don't just use it because it seemed to have given you the solution to the problem at that instant. You need to understand how it was developed because it might have performance implications on your code. Okay. And you just need to have that understanding how it operates so that when you put in your code, you can take ownership. If not, if you take the library and the library brings some more and less efficiency to your code, then you need to know. You need to know, especially when you're working in areas where efficiency is of importance. Let's say you're working in the aerospace industry and writing code that to use in aircraft, where they need consistency in performance and very high efficient code, right? So you don't just take something and bring that you don't understand how that thing was implemented. The complexities in it. It gives you what you want, but maybe what if they use for loop in a for loop to implement it? And you're probably getting the right answer because you're dealing with a small data set. But then when the data set grows, that thing will become very slow. And in that kind of industry, they need sharp, sharp answer, like highly efficient code, not codes that will be delaying. So I don't know if you understand what I'm saying. Basically, as a developer, you need to have that habit of reading, researching, trying out things like we just did here. Me, I didn't know this one before. As I tried it, now say, okay, works here too. And then you're able to research, read about certain things. Okay, let's go ahead. Let me bring back my code. So it should be coming. So the next one we'll talk about is continuation. So there are some times you might be writing maybe an if statement. Yeah, let's say you might be writing a code. You can say if A equal to B and A greater than 10 and A is less than. This might not necessarily be correct. I'm just throwing in things there. And A is greater than equal to B, just trying to achieve something here, okay? These are not necessarily true. But what I'm trying to bring out is as your code gets longer, right? You may want to bring this part. Maybe I want to take this part to the next line. You get? Because if it keeps getting longer, maybe it go off my screen and it's so long. You can achieve that by putting a backward slash like this. So at the end of this line, now where I want to break it, I'll put this backward slash and then I press enter. Then I continue my my statement. That's for a very long expression. that putting in one line might look somehow. You'll be scrolling to see the end. You may want to put it like this. Now, this brings us to something in two things that are important in good code is we talk about the code efficiency, and then you talk about how clean the code is. So when we're talking about that clean code, there are standards that you should follow or guidelines that are generally followed. One of such guidelines is called PEP 8. PEP 8, you can Google about it later. Just maybe you find a read up, you read about, just understand a little bit about what PEP 8 is. So it's a kind of guideline. PEP 8 is a very popular guideline in Python that tries to guide us on how we write our codes. For instance, when we talk about things like this, I think PEP 8 to say once you have up to 79 characters like this, going up to 79, you should break into the new line. So you should not have any line that is more than 79. Okay, it's just like a guide. You can, of course, have more than that, but it's like that PEP 8 is like a general standard, a guide for writing code in a certain way. If you read about it, see, there are many things you might not even understand or at this stage, but you can just be aware that, oh, there's a standard PEP 8. It says 79. Somebody else can have his own standard and say, okay, I need 100. Once it's 100, then you break. So in that case, how do you achieve it? You use this backward slash and you break. But if you are working on a list, for instance, for I in, if I had this list, 1, 2, 3, okay. My list is so long that it can't enter one line. In this case, you can just hit enter without backward slash, and it will work when you're doing something like a list. Okay. Dealing with an object like a list, a dictionary, a tuple, you can just break it like this without this. You can omit it in this kind of when you're dealing with this object.